What does it actually mean to build with Swift in 2027? It does not mean pretending that the future is settled or calling preview software stable. It means looking at what Apple and the Swift project have published by July 2026, separating shipping technology from the 2027 release cycle, and reading the trajectory. The verifiable baseline on this Mac is Swift 6.3.2 with Xcode 26.5. WWDC 26. Meanwhile, introduced Xcode 27, the 2027 operating system releases, and continuing Swift 6.4 work. This video therefore uses three labels: stable now, announced for the 2027 cycle, and reasonable projection. By the end, you should know what deserves production adoption, what deserves a prototype, and what still deserves a beta warning. The central idea is that Swift is no longer merely the language behind an iPhone screen. It now spans data race safety, mature declarative UI, observable persistence, local and private intelligence, coding agents, servers, Android, WebAssembly, and embedded systems. Entry is easier. The professional quality bar is higher. Start with the language. Swift 6.3 shipped on March 24, 2026. One of its most consequential additions is direct C interoperability through the @C attribute. A Swift function or enum can produce a declaration consumable from C, and Swift can implement an existing C declaration while the compiler validates the match. That may not change a Weekend Notes app, but it changes where Swift can sit inside long-lived libraries, firmware, and systems that have decades of C at their core. Module selectors use a double-colon to disambiguate APIs with the same name. This looks like a minor ergonomic feature until a large codebase imports multiple packages with overlapping symbols. Swift 6.3 also gives library authors more explicit performance controls, specialization for common generic types, guaranteed inlining for measured hot paths, and implementation visibility across an OBI-stable boundary. These tools are not permission to decorate every function. They are escape hatches to use after profiling demonstrates a real cost. In the Swift 6.4 cycle, Apple and the Swift project show further everyday refinements. The Any Apple OS availability form reduces repetitive platform checks, and @diagnose gives library authors finer control over diagnostics. We should describe those as part of the 2027 development line, not as the stable compiler already installed everywhere. The larger trend matters more than any keyword. Swift is reducing friction while opening stronger bridges to C, Java, and new execution environments. The 2027 language should be judged by how much of a product stack it can cover without giving up type safety, tooling, or predictable performance. Concurrency remains the most important mental model shift in modern Swift. In older systems, data races often surfaced as intermittent production defects. Two tasks mutated the same object, a view read halfway through an update, and the bug vanished under a debugger. Swift 6 moves much of that risk into the compiler. Actors, isolation, main actor, and sendable create explicit boundaries. When a value cannot safely cross one, the compiler can stop the build before a user finds the race. This does not make concurrency automatic. You still decide who owns mutable state, what belongs on the main actor, which work is cancelable, and which values are honestly sendable. The advantage is that those decisions are encoded in the program rather than preserved as tribal knowledge. For a learner, the useful sequence is simple. A task has a lifetime. Cancellation is part of correctness. An actor owns mutable state, and UI work normally belongs to main actor. State-of-the-art Swift is not async sprinkled over every function. It is structured flow. A search request cancels when the query changes. A view does not retain work after it disappears. A download reports progress without blocking interaction. A package states which values may cross domains and why. When the compiler objects, suppressing the diagnostic should not be the first move. Ask which boundary the design is crossing. Swift's promise is unusually concrete. A class of runtime failures can become a design conversation during compilation. That is more valuable than a shorter syntax for launching background work. SwiftUI is no longer the young alternative reserved for a simple settings screen. Apple's 2027 releases continue its maturation. Apps gain a refined liquid glass appearance. But the important idea is not the shine. System materials can evolve while a semantic hierarchy remains intact. Good teams still use glass to express navigation or depth, maintain contrast, honor accessibility, and avoid coding every surface merely because the effect is available. The expanded document APIs move SwiftUI into more serious document workflows, incremental reads and writes, direct document URL access, progress reporting, and custom creation sources let an app work on large files without loading everything into memory and hoping the user does not quit. New reordering APIs cover lists, grids, stacks, and custom containers. Swipe actions move beyond list. Item-driven alerts and confirmation dialogues align with the binding model already used by Sheets. Some of the best improvements are less photogenic. Async image gains standard HTTP caching behavior and configurable requests or URL sessions. In the Xcode 27 cycle, state becomes a macro, enabling lazy class initialization and avoiding repeated allocation. Content Builder unifies specialized result builders and contributes to better compile time behavior. These changes remove accidental code rather than adding another abstraction to memorize. Architecture still decides whether a SwiftUI code base scales. A view should express a transformation of state, not become a container for networking, persistence, analytics, and business rules. Observation makes dependencies easier to state. It does not replace boundaries. The state-of-the-art is an interface that adapts to size, keyboard, locale, reduced motion, and assistive technologies. SwiftUI provides better primitives, but product judgment still decides what information belongs on screen. Data and tests are where a demonstration becomes a product. In the 2027 cycle, SwiftData adds section fetches, persistence for custom codable types, and observers that react to results or store history outside a SwiftUI view. Results Observer can drive state objects and services. History Observer can process transactions for indexing, synchronization, or audits. Those capabilities expand the architecture, but they do not make schema migration risk disappear. A production model still needs explicit versions, migration tests, and a recovery story. Swift testing is maturing at the same time. For new code, add test, expect, parameterized cases, parallel execution, cancellation, and issue severity provide a concise modern model. For existing projects, Apple's guidance is incremental rather than ideological. Xcode and Swift testing can interoperate while teams migrate helpers and suites in small pieces. Xcode remains necessary for UI automation, performance testing, and some Objective-C exception scenarios. The professional choice is deliberate coexistence, not a rewrite performed to satisfy fashion. The combined standard is straightforward to describe and difficult to fake. Explicit data migrations, cancelable operations, invariant tests, parameterized edge cases, and UI automation for the journeys that generate revenue or protect user data. Use instruments before declaring an optimization. Record a baseline before changing an implementation. In 2027, an agent may generate thousands of lines quickly, but evidence still separates a trustworthy app from a persuasive prototype. Now to the shift receiving the most attention. Building intelligent features from Swift. The Foundation Models framework first exposed Apple's on-device language model. An app creates a language model session, supplies instructions, sends prompts, and can receive typed Swift values through guided generation. With the @generable macro, the model does not merely return a string that you hope to parse. It samples against a schema and produces a value shaped for your program. Tool calling lets the model request operations you define. That supports extraction, classification, summarization, structured planning, and agentic experiences without uploading every piece of context. For the 2027 cycle, Apple expands this into a model abstraction layer. The rebuilt on-device model accepts images in prompts. The same framework can represent the system model, Private cloud compute, models packaged through Core AI, the MLX ecosystem, or compatible providers. Apple describes a private cloud compute model with reasoning and a 32,000 token context window under its privacy architecture. It also says developers are not charged per token for that model, while availability, entitlements, usage limits, and regional support still have to be handled. No token bill does not mean infinite capacity. A responsible architecture begins with a capability matrix. Is Apple Intelligence available on this device and in this language? Can the task fit on device? Does it need an image? Does it require server reasoning? Is the network present? What useful fallback appears when no model is available? Language model session keeps a transcript, supports pre-warming, and reports context size failures. Instruments can expose token use and latency. Evaluation suites should measure quality rather than relying on one impressive prompt. State-of-the-art does not mean placing a chatbot in every tab. It means bounded jobs, structured output, safe tools, explicit consent, and a non-AI path. Sensitive data should stay local when the job allows it. Cloud use should be visible. Any tool that mutates user data needs validation and confirmation. Swift provides an elegant common layer. Product judgment decides whether intelligence reduces work or simply decorates a demo. Xcode 27 moves coding agents into the main development loop. Apple describes 4 modes of work: explore, build, refine, and orchestrate. An agent can inspect a project, identify patterns, propose a feature, invoke tools, run tests, and help polish the result. Domain skills bring repeatable guidance for SwiftUI conventions, test migration, translation, and other focused workflows. This lowers the cost of entering an unfamiliar code base and applying a known practice consistently. An agent, however, does not automatically receive the context in your head. It needs a verifiable objective, constraints, relevant files, and a definition of done. Improve the app converts ambiguity into edits. Reduce this screen's cold load time without changing its public API. Measure before and after. Preserve the tests gives the agent evidence to work against. The 2027 developer is not removed from the loop. The role moves upward. You review architecture, permissions, diffs, tests, privacy, and experience. You split work so a data migration is not casually bundled with a visual redesign. You keep version control and demand an explanation before dangerous commands run. Agents accelerate exploration and execution. Accountability does not transfer. The scarce skill becomes turning product intent into an executable contract that another intelligence can follow and that a human can verify. Another major shift is Swift's reach beyond Apple platforms. Swift 6.3 includes an official Android SDK. Swift compiles to native code and ships a runtime containing the standard library, Dispatch, and Foundation. Android's platform APIs primarily live behind Java and Kotlin, so the Swift Java project generates bindings in both directions. This does not imply that every Android interface should suddenly be written in Swift. It does mean that a networking, domain, cryptography, or data package can treat Android as an official target and share more logic without abandoning types or native performance. Swift is also advancing in WebAssembly with JavaScript Kit, on servers through a growing package ecosystem, on Windows, and in embedded systems. Embedded Swift reduces runtime requirements for microcontrollers and benefits from better C interoperability and targeted diagnostics. In numerical computing and machine learning, MLX Swift offers tensor operations, automatic GPU execution, and automatic differentiation while keeping code in a type-safe Swift toolchain. The conclusion is not that one language replaces every other language. It is a better architecture question: which core deserves portability, and which interface should remain native to each platform? Swift can participate in firmware, a service, a shared library, Android, and an Apple client. That reach makes small modules, explicit dependencies, and stable contracts more important. Swift's cross-platform future will be credible when teams can test, distribute, profile, and debug those packages without turning portability into an invisible layer of operational complexity. Given this landscape, what should you learn next? If you are starting, do not begin with agents or a 32,000 token model. Begin with values, optionals, functions, collections, and errors. Build a small interface with SwiftUI and understand how state drives rendering. Persist a model with SwiftData. Add one cancelable asynchronous operation. Write tests for logic that must not regress. Only then add one foundation model's feature with a bounded result, such as classification, summarization, or structured generation. If you already ship Swift professionally, the priorities change. Enable strict concurrency and understand each isolation boundary. Migrate tests incrementally. Profile with instruments. Review data migrations. And place model access behind an abstraction that supports fallbacks. Try Android or WebAssembly with a small package before promising a cross-platform strategy. Treat Xcode 27 and Swift 6.4 as 2027 cycle technology while they continue to evolve. A practice project can connect the whole map. A habit app with SwiftUI, local persistence, optional sync, and on-device suggestion, parameterized tests, accessibility, and a shipping pipeline. The goal is not to collect frameworks. It is to demonstrate a complete loop. Define, build, verify, measure, and ship. Swift in 2027 rewards developers who connect the pieces deliberately. The conclusion is simple. Swift is becoming a language for the whole system, not only the screen. What is stable today is already substantial. The 2027 cycle adds new layers of UI, data, intelligence, agents, and platform reach. Learn the fundamentals, adopt previews with evidence, and keep fallbacks. If you want a structured path through production SwiftUI architecture, strict concurrency, SwiftData, on-device intelligence, testing, security, and shipping. I am the author of Swift 2027, the definitive guide. The English edition link belongs in the pinned comment. This video gave you the map. The book turns that map into deliberate practice.